How's it going, guys? It's Matt and I've got another chem video for you. This one is ionization energy. What is ionization energy? Well, I would define it as the energy required to remove an electron, which in turn makes an atom more positive. When we look at the periodic table, we can see a trend. As you go from left to right and down to up, ionization energy increases. Now, atoms love being stable, meaning their outermost electron shell will be full. This means the closer they are going backwards to a noble gas, the easier it is for them to become stable. For instance, if you go just below hydrogen to the alkali metals, it is very easy for them to get back to a noble gas. If an electron is removed from lithium, for example, it will have the same amount of electrons as a stable helium. The fact that it is easy for lithium, or typically any element on the left side of the periodic table, to become stable means that the ionization energy is low. Unlike lithium, elements that are already stable, such as the noble gases, have a very high ionization energy, and that goes with typically any element on the right side of the periodic table. Now, as you can see with the graphic representation of ionization energy, the trend is not perfect. As you can see, beryllium has a higher ionization energy than boron, even though boron is closer to the top right corner. Not only does this happen once, but as you can see, it happens somewhat often. Speaking of ionization energies, there's multiple of each, except for hydrogen, since it only has one valence electron. Others, however, have several and are shown in this chart. If you can read aluminum, you'll notice a large jump in the energy it takes to remove the fourth valence electron. This is because aluminum becomes stable after taking the third valence electron away. And as we know with stable molecules, they want to stay that way. Okay, now that you know some stuff on ionization energy, it's time for some practice problems. First, which has a higher ionization energy, lithium or tin? I'll give you some time to think it over. If you said tin, you were right. Good job. If you didn't, keep working at it. Second, which ionization energy level does beryllium become stable? I'll give you a few minutes to think this over. Okay, did you say second ionization energy? If you did, great job. If you didn't, just keep working at it, man. Lastly, does nitrogen or oxygen have a higher ionization energy? And my hint here is, think of the exceptions I showed you earlier in the video. I'll give you a few seconds to think this one over. Okay, if you said nitrogen, awesome. If you didn't, just keep working on it. Okay, that's all from me. I hope you enjoyed it and I hope you learned something. Adios.